Good evening, everyone. I trust we are doing well. Today marks session 11 of you getting a very simplified introduction to robotics. So far, you've made great progress. And in yesterday's session, we looked at microcontrollers. We looked at how they communicate. We just explored a few things. In yesterday's session, you took a look at the communication protocols, right? And we mentioned that as just a form or a way microcontrollers use to communicate. So if you have one microcontroller on the left and if you have one microcontroller on the right, if you want them to communicate together, if you want them to share data, if you want them to talk to each other, um, these are the three very simple communication protocols or ways in which these two microcontrollers are going to be communicating with each other. So we have one UART, and we took a look at that. The full meaning of that is Universal Asynchronous Receiver Transmitter. So that is UART. And then we took a look at the second one, I2C or I2C, and that means inter-integrated circuit. And I think we elaborated a little bit on that. And we noted that it's just integrated circuit here, integrated circuit. We got to know that on an electronics board, you're going to have lots of components on there. You're going to have lots of the integrated circuits on the components that have multiple pins. Some have 6 pins, some have 8 pins. For example, microcontrollers. So if you want integrated circuits to communicate together, if you want them to, interrelate, that's when you can also use the I2C communication protocol. So that is inter-integrated circuit. All right. And then we have serial peripheral interface, SPI, serial peripheral interface. So these are the very um, 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 foundational communication protocols in electronics. If you want one chip or one microcontroller to communicate with another microcontroller or another chip, these are the 3 communication protocols we are taking a look at. UART, one, I2C, the second one. The third one is SPI, serial peripheral interface. Good. And then in yesterday's session, you also made some very good progress. You took a look at the ATmega 328 microcontrollers pin out. And the word pin out just means what we are taking a look at. So this pin is labeled PC6. There's another pin labeled PD0. There's another pin labeled PD1, PD2, PD3, PD4, PD6 here, PD7, PD5, PD6, PD7, PB0, PB1, all of the namings here and what they do. So if we take a look at PD0 here, which has a natural number on the microcontroller as pin number 2, you can see that there is something written here, RxD, right? RxD. On pin number 3, you see TXD. So what does RxD mean? What does TXD mean? If we take a look at pin number 28 from this side, 28. So that is PC5, right? And you can see something like ADC5. What does ADC5 mean? What does SCL mean? This one here, SCL, right? We have ADC4 on pin 27 here, PC4, right? You can see ADC4, you can see SDA. What do all of these pins mean, right? And that's what we call pin out. Whenever you have a microcontroller and you label the pins and what they do, that's what we call pin out. It's nothing complex. So I think we can put it in the chat, pin out. So I think we put it in the chat in yesterday's session. But yeah, this is it, pin out. So that's so simple. All right. So yeah, we took a look at the ATmega 328 microcontroller, the one found on the Arduino board. we took a look at some of the pins here and how they are classified. We are going to be getting back to onto it in just a second. But this is the 80Tiny85 microcontroller, and this is also the pin out for it. So when you take a look at the 80Tiny85 microcontroller, you see ADC0 on pin 1 here. You see ADC0, which is the same as PB5. You see PB3, PB4, and we have worked with this microcontroller before. Everyone here, you have worked with this before in our introductory sessions. You worked with this 80Tiny85 microcontroller. We did some connections, right? And then we wrote some code onto it. Great. And apart from those pins, we also have 7 pins here, PB2. It also has SCL written on it. And in today's session, we're going to be taking a look at what all of these letters or all of these inscriptions or acronyms mean. So SCL, what does it mean? SCK, what does it mean? If it says MISO, MISO, what does it mean? If it says MOSI, what does it mean? Right? We're going to be taking a look at all of these things in today's session. And so quickly, let's go into it. All right. So let's go on to an illustration here. Let's go on to an illustration here. I believe it should pop up in just a second. Are we all able to see it? Yes, I believe we all are able to see it. Give me a thumbs up if you're able to see the illustration here. All right, Michael, Bernard, all right. Abdul Salam, that's great. Who else? Herbert, Felix, Emmanuel, all right. All right, that's great. Isaac, all right, that's great. Great. In team, all right, that's great. Elvis, all right, that's great. Good. So if you have two microcontrollers, or if you have two integrated circuits, if you have two chips, right? So we have chip 1 here, we have chip 2 here, right? Chip 1 on the left, we have chip 2 on the right. So if you have these chips here, if you have one here, you have another on the right. If you want these two chips to communicate together, right? Just as on your computer, if you take your laptop apart, you can see the green board, right? And the green board has lots of components. There are lots of chips on the green board, on the printer circuit board. Now, you have opened your laptop. You have taken some chips from your board or your electronics board, and you want these two chips to communicate together. We have already mentioned that there are 3 communication protocols we're taking a look at. We have UART, we have I2C, and we have SPI. Now, if you want these two chips to communicate together, you can choose any of these 3. Right, you can choose to say Benedict can choose to say, okay, hey Bernard, for this project that we are working on, let's go for the UART communication protocol, so that our chips, chip 1, the chip on the left and then the chip on the right, can share data together, right? So that they can communicate together. Good. And then Elvis and Emmanuel may say that, okay, for us, for our project, we want to go for the I2C communication protocol. We want to use the I2C communication protocol for our chip on the left and then the chip on the right to communicate together. And then Felix and Herbert may say, okay, for us, we want to go with the SPI because we understand it better, right? Or there are, and all of these communication protocols have advantages and disadvantages, right? Good. So Felix and Herbert may say we want to go for the SPI, serial peripheral interface, and there are pins on the microcontroller that you are supposed to connect together with wires, right? So yeah. But even before we go into this and then take a look at it, we need to know what the pins what those pins we have a pin here called TXD. What does it mean? What does TXD mean? What does RXD mean? We have another pin here called SCL. What does it mean in full? And then we also have another pin here. It's called SDA. What does SDA mean? What's the full meaning of SDA? We also have MOSI, MOSI, right? What does it mean? MISO, what does it mean? What's the full meaning? SCK, what does it mean? And then we have reset or CS or SS. What do all of these acronyms or these short forms mean? So let's go for the first one. The first one is TXD. Now let's make this interactive. Who has an idea? Perhaps you predict that the TXD may mean something. If you have an idea, raise your hand and unmute and tell us. TXD, what does it mean? Okay, how about RXD? Any idea? Any idea from us? Rodi Fimpon, Michael Oputi, Isaac. All right, Michael, please go ahead. Please go ahead, Michael. Looks like you're muted. We're unable to hear you, Michael. But I think yeah, it's so simple and everyone will be able to appreciate it. Let's go straight into it. So TXD, just as we can see TX is so simple. It means transmit, right? TX means transmit, and D here means data. So transmit data. Good. We have a hand raised. Oh, oh, Michael, you're having a problem with your speaker. All right. Perhaps you can go off the session and then join again. If that can fix it quickly for you. Yeah, you can just do that quick trick and hopefully can fix it. Otherwise, you can just use the settings on your below your meeting interface, and you can do adjustments to your microphone, your speaker, and all of those things. All right, but yeah, let's take a quick look. So we have TXD. TXD means transmit data. So simple. The TX is transmit, and then D is data. So transmit data, and RXD receive data. So simple. And then we have another one here, another pin called SCL. This is serial clock line. So S means serial, C means clock, and L means line. So serial clock line or serial clock. Simple. And then SDA means serial data. So S serial, DA means data. So simple. So serial data. So and then we have MOSI. MOSI, MOSI, it means master out, slave in. Master out, slave in, right? And then we have another pin called MISO, MISO, master in, slave out. So master goes in and then slave goes out. And then MOSI, master goes out, slave goes in. All right. And then we have another pin here called SCK. That also means serial clock. That this SCK and SCL usually they mean the same thing. So they are all serial clock. So if you see SCL, it's serial clock. If you see SCK, it's serial clock. Good. And then we have the last pin here. It's called reset. Reset. It's just like the name goes, reset. That's so simple. And or this same pin, it's like it's like you ask someone what's your name, and then he or he says my name is Michael Oputi, aka like those things that people used to say, aka, so also known as. So the same pin is called reset. That same pin can also be called CS, and that the CS means chip select, right? C chip, and then S select. So CS means chip select. And then that same pin may also be called SS, which means slave select. So I believe we have covered it. The last pin here, it's called reset. That same pin, it has another name called chip select. That same pin has another name called SS, slave select. So it just has 3 names. So any of them you can we have okay. So in Abdul Salam may say, okay, I want to choose to call it reset. It's so simple. It means the same thing. Isaac may say that I want to call it chip select, CS. We are referring to the same pin. And then okay, looks like someone wants to join. All right. Yeah, and then we have yeah, Isaac may or in team may say, I want to call it SS. I want to call it chip select. So it's so simple, right? But yeah, let's do a quick recap of what the pins that we have taken a look at. So for UART, we're looking at 2 pins. We have we have TXD, which is transmit data. There's no need mentioning TXD. You can just say TX, right? Transmit, and then you have receive. Good. So these are the 2 pins involved for UART communication. TX, RX. Good. And then you have I2C communication protocol. For I2C communication protocol, there are 2 pins involved. You have SCL, serial clock, right? You have serial clock here, you have serial clock here. And then you have serial data here, you also have serial data here. So we have 2 pins for I2C communication protocol, serial clock and serial data. These are the 2 pins used for for I2C communication. And then we have SPI communication. So for SPI, there are 4 pins involved. 4 pins involved. So if you want this chip, if you want this microcontroller here to communicate with this microcontroller here, there are 4 pins on the microcontrollers that you are supposed to connect. So on the left microcontroller, you're going to find MOSI on it, master route slave end. Good. And then on the right microcontroller, you're going to find the same MOSI on there. So you just have to connect those 2 pins together. MOSI, just connect them together. Good. And then we have the second pin, MISO, master read, slave out. So you connect for your left microcontroller, you connect its MISO to the right microcontroller's MISO. Good. And then we have the third pin. The third pin is called serial clock, SCK. So if you want your left microcontroller to communicate with the right microcontroller, you have to connect the MOSI, MISO, serial clock, SCK, and then the final pin called CS or SS or reset. Reset, chip select, or slave select. Good. So this is basically communication protocols when you're dealing with electronics. If you want one chip to communicate with another chip, all you have to do is just connect the pins. And for the UART communication protocol, this is what you do. We can see that for the UART communication protocol, we do not use any arrows here. So let's do this. Let's get the arrow here. So for the UART communication protocol, you do not connect TX to TX. No. You do not connect transmit to transmit. No. You rather connect. So let's do this. Let's rotate it. Let's rotate it a little bit. Yeah. So let's see if okay, undo. All right. Let's move this here. No, undo. Let's bring this arrow here, and let's rotate it. Oops. Yeah. Good. So yeah, let's rotate it down, and then let's bring it. Oops. Undo. Let's bring it here. Good. Undo. All right. So for the UART communication protocol, come on. Let's bring this arrow down here. Undo. Come on. Why is this thing not working? Undo. Okay. So let's do this. Let's use the arrows here down. So for the UART communication protocol, you connect the TX to RX. So if you want these two chips or these 2 microcontrollers to speak with each other, if you want the left one to send data to the right one, and and the right one can also send data to the left one. They can both receive and they can both transmit. They can give and receive data. If you want them to communicate, you connect the TX of your chip 1 to the RX of your chip 2, and then you connect the TX of your chip on the right to the RX here. So you interchange them. You connect TX to RX and RX to TX. So I believe that was simple. That was simple, right? Let's do this. Good. So that's it. So TX to RX and RX to TX. Let's reverse this. Good. And then let's move it here. Great. Great. I believe that's great. So that's it for UART communication protocol. There are just two pins involved. We have RX, we have TX. So you just have to look on your microcontroller. You just have to look for the pin labeled as RX. You just have to look for the pin labeled TX, and then you connect the TX to RX, right? And then you connect RX to TX. Good. That's it. And then we have I2C. In just a second, we are going to be taking a look at these pins, the actual pins on the microcontroller, and how we can be able to connect them. Good. So we have TX here. Oh, that's UART. So for I2C communication protocol, there are just two pins involved. There is serial clock and then serial data. So all you have, and for this particular one, for this particular communication protocol, I2C, you don't connect opposites, right? You do not connect TX to RX and RX to TX. No, you rather connect the same thing. So you just look on your microcontroller on the left. You will see serial clock on it, labeled on it. So that pin, you connect it to the same serial clock on your other microcontroller. So serial clock on this chip, it will be connected to serial clock on this particular chip here. Good. And then serial data. So for serial data, you just connect serial data on this chip here to serial data on this chip. I believe this is simple. This is simple, right? Give me a thumbs up until now for UART communication protocol and I2C communication protocol if everything is clear. Give me a thumbs up if everything is clear, everything is simple. Alex is good. Michael is good. All right. Abdul Salam, are you good? Benedict is good. Abdul Salam is good. And Tim is good. All right. All right. Isaac is good. All right. All right. That's great. Herbert is good. All right. That's great. That's great. Emmanuel, are you good? Emmanuel, are you good? In Tim, are you good? Michael Opoti, are you good? Roddy Frimpon, Roddy, are you good? All right. All right. All right. Great. So it's so simple. So whenever you open up your computer or a TV that is sport, that's how those chips on the board are communicating. They are either using UART communication protocol, they are either using I2C communication protocol, they are either using SPI communication protocol. Now let's take a look at the last one, SPI communication protocol. So you just have to look on your chip. The first chip here, you are going to see MOSI. You just have to connect MOSI to MOSI, right? You just have to connect MISO to MISO. And then you connect SCK to SCK, serial clock, right? And then you connect the reset to reset. That's so simple. And that same pin, we keep emphasizing on this. That same pin is called chip select, CS. That same pin has another name called SS, slave select. So you just have to connect these pins together, and that's it. Now let's identify these pins on our pin out, right? On our pin out of our microcontrollers. And let's just take note of the very few important information we need to take a look at. All right, now let's go back into our presentation here. Great. Good. So now we know about the communication protocols, right? We know about UART communication protocol. We know about I2C communication protocol, and we also know about SPI. We also know about serial peripheral interface. Good. And we know the pins involved. We know the pins that are used, the pins involved in all of these communication protocols. Good. Now, okay, so yeah, so that's it. UART, I2C, SPI. Good. Now let's take a look at these pins. So if you are doing UART communication protocol, where you are going to use TX and RX, if you are using UART communication protocol, where you're going to be using two pins, TX and RX, how do you identify them on the pin out? And it's so simple. It's just going to be labeled, right? I believe we can see here pin 2. Pin 2 here is labeled RX. I believe RxD, receive data. Are we all able to see the RxD there? Give me a thumbs up. Michael Opoti is good. Okay, Michael is good. Benedict, Agnes, Felix is good. Abdul Salam is good. Agnes, are you able to see it? Bernard, Elvis, are you able to? All right, Herbert is able to see it. Bernard, are you able to see it? Elvis, okay. In team, you gave me a thumbs down. Where okay, let's where are you unable to see? Which part are you not good at?
Good evening.
Yes.
Hello.
Go ahead. Yes.
Hello. Please,
Yes,
can you
in
go
team.
back to the recent one you just said? That's where I couldn't get.
Oh, all right. So that's RxD. So we have pin 2 here, right? If you look
Okay.
at the AtMega, if you look at the AtMega 328 microcontroller here, you can
Okay.
see pin 2. Pin 2 has been labeled as RxD.
Okay.
RxD. I believe you can see it. Can you
Yes.
see it now?
Yes.
All right, so that is the RX pin. So
Okay.
if you want, all right, good. If you want two Atmega 328 microcontrollers, if you want these two chips to communicate with each other, if you have two of these chips and you want them to communicate with each other, if you want them to send data from one to the other, all you have to do, if you are using the UART communication protocol, all you have to do is just take note of the RX pin here. This RX pin, pin 2 here is RX pin. Good. And then we can also see TX pin here. I believe everyone can see TX. Give me a thumbs up if you can see TX. TX. So we are done with RX. TX, are you good? Abdul, Bernard, all right. Michael Oputi, all right. Felix, all right. Herbert, Elvis, all right. All right. That's great. That's great. Agnes, are you good? Benedict, are we all able to see it? Bernard, Elvis, Isaac, in team. Roddy Frimpon, are we all able to see it? All right, that's great. That's great. Good. So for UART communication protocol, we are only using two pins. So if you have your microcontroller on your left and you have your microcontroller on your right, all you have to do is just connect RX to TX of the other microcontroller, and then you connect TX to RX of the other microcontroller. So now we've been able to identify the RX and TX pin. Good. What if you do not want to use UART communication? You do not want to use the UART communication protocol, right? Now you want to, let's say, go with the I2C communication protocol, which also uses just two pins or two lines, right? SCL and SDA, right? Serial clock and serial data. Good. So let's identify those I2C pins on a microcontroller. So we have SCL, right? So let's scroll through. Let's see which pin is labeled SCL. All right. We don't see any SCL here. All right. So yeah, we can see SCL here. So pin 28 here, pin 28 on a microcontroller. That's the pin that is used for SCL, serial clock. So that's SCL, right? And then now let's take a look at let's search for SDA, serial data. So yeah, we can see just below yeah. So pin 27 here, it's labeled SDA. So that's what it's used for, serial that's serial data, and that's these two pins, serial clock and serial data. These are what are used for I2C communication protocol. So if you have two of these microcontrollers, let's do this. Let's paste. So we have two images here. Let's do this. So we have one at mega microcontroller here, and we have another on the right, right? Good. Now, if you want these two microcontrollers to speak with each other, if you want them to send data from one to the other, if you want this one on the left to speak with this one, if you want this chip to communicate with this chip, and you are using the I2C communication protocol, all you have to do is just search for your serial clock and then your serial data. So you just connect your serial clock, pin 28 here, to pin 28 here, serial clock to serial clock, and then serial data to serial data. Good, that's it. So that's for I2C communication protocol. Good. We're going to be going into detail for all of these communication protocols that we're taking a look at. But in today's session, we're just walking, right? We're just doing an introduction. Good. But yeah, we are done with UART communication protocol, RxTX, and then I2C communication protocol. I2C, we also have two pins involved: serial clock, serial data. So you can see serial clock here, SCL, and then you can see serial data, SDA here. In the same manner, you can see on this particular chip also see SCL and SDA. So all you have to do is just connect them together, and that's it. You're done. Good. Now let's move on to the last communication protocol, the third one, SPI, Serial Peripheral Interface. Now, I believe as of now, everyone has noted that when you want to do UART communication, you use just two pins. Also for I2C, you use just two pins. But for the third one, for the SPI one, for the serial peripheral interface, there are 4 pins involved. There are 4 pins: MISO, MOSI, MISO, MOSI. What else? Let's take a look at them. Let's take a look at our illustration here. I believe everyone is able to see it. All right, good. So yeah, we have MISO, MOSI, serial clock, and then chip select or reset. So 4 pins involved. So for UART, just two pins. For I2C, just 2 pins: serial clock, serial data, transmit, receive. But for SPI, you need 4 pins from your left microcontroller to connect with your right microcontroller so that they both communicate together. And those pins are MOSI, MISO, serial clock, and chip select or reset. Good. Now let's identify the MOSI, MISO, serial clock, and reset slave select or chip select pins on the microcontroller. Good. Let's take a look at them. Great. So we are still using the ATmega 328 microcontroller as an example. Good. So on the ATmega 328 microcontroller, let's identify the MISO, MOSI, serial clock, and reset pin. Good. So right off the bat, I believe we can all see this. We can all see the reset pin here. So this is the reset pin, pin 1. Pin 1 on the microcontroller has been labeled reset. I believe everyone can see the reset pin. Give me a thumbs up if you can see the reset pin. All right, Bernard, that's great. Isaac, are you good in team? Are you able to see it? Michael, Abdul Salam, Elvis, all right, we're good. Agnes, are you good? Felix, all right. Isaac, all right. Elvis, good. All right, good. Isaac is good. Elvis is good. All right, that's great. So so we have taken a look at the reset pin here. So this is the reset pin. And on this second mic, on the for the microcontroller on the right, we can also see that reset pin, right? So there's the reset pin. Good. Now let's go forward. Let's take a look at the MISO pin. So we can see here pin 18. Pin 18 here. We can see the MISO pin. So we can see MISO, MISO. Good. And then we can see pin 17, MOSI, MOSI. So we can see these 2 pins. So pin 17 is the MOSI, pin 18 is MISO. Good. And then finally, pin 19. Pin 19 here is SCK, serial clock. Serial clock. So we've been able to find all of the 4 pins used for SPI communication, serial peripheral interface. So if you want this microcontroller on the left here, communicate with this microcontroller on the right here, through the SPI communication protocol, all you have to do is just connect your reset, right? Your reset pin to reset. You connect this microcontroller's reset to reset on this microcontroller, and then you connect MOSI on this microcontroller to MOSI on this microcontroller, and then you connect MISO to MISO and serial clock SCK to serial clock SCK. So I believe that's so simple. Are we all good? Give me a thumbs up if you're good up until now. All right, Michael is good. All right, Felix is good. Herbert is good. All right, all right, all right. That's great. That's great. That's great. That's great. All right. That's great. That's great. All right. So now let's take we have a few minutes left. Let's take a look at what these pins actually do and how the communication happens, right? If we go into if we go into our illustration here, good. If we go into our illustration here, we can see that the UART communication is so simple. It just has TX and RX. So if you want this chip, if you want this microcontroller to send data to this microcontroller, right? All you have to do is just in your code, you just have to write instructions in your code that you write. When you are programming the microcontroller, all you have to do is just say that, hey, microcontroller, I have connected your TX to RX of this microcontroller. And then you also write the code onto this microcontroller, and then you tell this microcontroller also that, hey, microcontroller, I have connected your TX to RX of this microcontroller, right? And then you just let them communicate with each other. So that's so simple. So if you want to transmit data, use the transmit, use the receive, and then you do that. So simple. Good. And then when we take a look at I2C communication protocol, we have serial clock line, and then we have serial data line. So these two pins are what are used for communication, right? Actually, the serial clock line here, just as we can hear the word clock in there. Whenever we mention clock, we are referring to time, right? We're referring to timing. So serial clock, whether it's SCL or whether it's SCK, they just as their names sound, serial clock. They do something related to time. They do something related to clock. So they make sure that your first microcontroller is speaking with your second microcontroller, precisely or accurately in terms of time. So let's say on the literal term, your first microcontroller will say that, hey, second microcontroller, I want to send some data. I want to send some sensory or some sensor data to you in just a second. Or I want to, hey microcontroller, I'll be sending some data to you in 5 minutes, right? So that's what's happening. So that is it. So serial clock and then serial data. Good. And then we'll be going into detail once we are doing some connections, once we are doing some actual communication between microcontrollers. Good. But for the SPI communication protocol, we know that since it has 4 pins, MOSI, MISO, serial clock, and reset, it's totally different from the UART communication protocol and from the I2C communication protocol. And so, yeah, let's treat it as such. So the MOSI here, just as the name sounds, master route, slave end. And I think we should, yeah, let's just write that here. Let's just write that here. So yeah, let's label that as master in. So that's MOSI, right? Master route, slave end. Good. Good. So now let's elongate it a little bit. Good. Master out, slave in. Good. And then we have master in, slave out. Now, what does master out, slave in do? So if you want the first microcontroller here to speak with the second microcontroller here, if you want the first microcontroller here, and for SPI communication, we are not going into detail, but for SPI communication, it happens, just as the name goes, master out, slave in. So we have two names here, master, and we have slave. So it's like one of the microcontrollers should act as a master, and one of the microcontrollers should act as a and there can be multiple slaves, right? But we are looking at two microcontrollers. So just as the saying goes, two masters cannot be in a ship, right? Or what is it? How is it actually mentioned? They say two captains cannot be on the same boat, right? Yeah. So there should compulsorily be one master. There should compulsorily be a master on the ship. Good. So yes. So for SPI, you need to tell one of your microcontrollers to be the master, and then you can have many slave microcontrollers. So you can have one microcontroller in the middle, and that's the master microcontroller. And that particular microcontroller can be able to connect to so many devices or so many microcontrollers. Now, let's not make this complex. This is so simple. Once we go forward, everyone here will be able to appreciate it. But like we've been saying since we started the program, sometimes when you hear something for the first time, it may not really sound well. You may not really understand it. You may not really appreciate it. But when you hear it on the second time, on the third time, when you hear it, for quite some time, you get to appreciate it. I believe everyone here is making progress gradually. So master out, slave in, just as the name goes, master out. So that's when the master wants to speak. The master wants to speak out. The master wants to send data out of it into the slave. So that is it. Master out, slave in. So this means that the master microcontroller here on the left is going to be sending some data. It's going to be speaking out. It's going to be sending some data out of it into the slave. So that's why it's called master out, slave in. Good. And then now let's go on to the second one, MISO. Good. So let's go on to the second one here, MISO. And what does MISO mean? MISO means master in, slave out. So yeah, master in, slave out. Slave out. Good. So that's it. Master in, slave out. So this means that the master is now so if you want to really understand MOSI and MISO and the difference, I want everyone to pay attention to the out. Pay attention to the out, the word out, right? So you can see that for the first pin, it says MOSI, master out, slave in. So that's why we are saying pay attention to the out. So if it says master out, it means it's the master it's the master microcontroller that is speaking. So it's the master that is sending some signals or some data or some instructions onto the slave microcontroller. Good. But if you hear master in, slave out, pay attention to the out. So it says slave out. So now the slave also wants to talk. The slave also wants to send data to the master. So they are communicating. So we can have one person on the left, one person on the right. The person on the right, the person on the left may be the master. The person on the right is the slave. So at a point in time, the master will ask the slave, "Hey, did you get the job done?" Right? That's when the master is speaking out. Good. After the master speaks out to the slave, the slave now wants to answer the master and then give an answer. Right? So the master says, "Hey, are you done with the job I gave you?" And then the slave says, "Yes, I'm done." That's simple, right? So now the slave is speaking out. So that's why we have master in, slave out. So that means now the master is listening to the slave. The master is taking in information from the slave, and the slave is giving out information to the master. Good. So it's it's so simple. So the master is going to send data to the slave, and then the slave is also going to send data to the master. Good. And then the serial clock here, SCK here, it's so simple. Like we've mentioned, clock. It ensures timing. It ensures timing. So it makes sure that the master and then the slave are both communicating within time. So if the master says, I want to send, hey, what did you get the job done? Right? If the master asks the slave this question, everything happens within time, right? So that, you know, they are able to communicate effectively. So serial clock makes sure that they are both, these two chips, these two microcontrollers are speaking on the same speed level, right? Good. And then we have reset here, reset. Now, when you have just two microcontrollers speaking with each other, the reset pin here, or the chip select pin here, what it's used for is the master can choose to turn the slave off. The master here, it chooses to turn the slave off by using the reset pin. So it can turn the slave off to say that, hey, now I do not need anything from you. So hey, go to sleep, right? Go to sleep or turn off. So the master, and like we've mentioned, for the SPI communication protocol, the SPI communication protocol, you can have multiple devices. It's the same way for I2C. We're going to be going into detail. But for SPI communication protocol, you can have one microcontroller as the master. You can have multiple microcontrollers, like about 5, 10 microcontrollers that have been connected to the master. And the master can choose to speak with either of them, to any of them, right? So the master can choose to speak to the first slave or the first microcontroller by sending some on and off signals through the reset pin, right? So if you have about 5 microcontrollers connected to the master microcontroller, the master microcontroller may say that, okay, I want to speak with the 5th microcontroller, or I want to speak with the 2nd microcontroller. So if it is speaking with the second microcontroller or the 2nd slave, it is going to turn all of the other microcontrollers off, all of them off, and it will be speaking only to the 2nd microcontroller. Now, what if it's done speaking with a 2nd microcontroller, and now it wants to speak with the 1st microcontroller? So all it has to do is just turn all of the other 5, all of the other 4 off, and then speak to just the first one, right? So if you want to speak with the first one, it will turn all of the others off and then speak to it. If you want to speak with a 2nd microcontroller, it turns all of the other microcontrollers off and then speaks with. But I believe, you know, like we mentioned, you're hearing it for the first time, and so just do not struggle to understand anything. Do not, you know, struggle to do anything. Just appreciate it. Just hear it. And in our next session, today is Sunday. On Monday we're going to be doing mechanical design. But in our next session on Saturday, we're going to be appreciating all of these things really, really well. So in today's session, I believe we have achieved the goal. I believe everyone here, you've achieved your goal of understanding how microcontrollers communicate. We've taken a look at UART. We've taken a look at I2C. We've taken a look at SPI. All right, Abdul Salam. Everyone, give me a thumbs up if you've made some progress today. Agnes, Benedict, all right. Bernard, Herbert, all right. Elvis, are you good? Felix, is everyone good? Everyone, give me a thumbs up if you're good. If you've made some progress today. All right. So yeah, that's it. That's it. UART communication protocol, I2C communication protocol, and SPI communication protocol. All right. On this note, let's bring today's session to a close. But first, do we have any question? Just a few seconds for a question. If you have a question, please raise your hand up, and you can unmute and ask. All right. I believe everyone is good. All right. In light of no questions, let's all have a good night. We're going to be connecting in tomorrow's session. Bye. Bye, everyone. Bye.